Well, hello and welcome to our development live stream for March 2020. And hello Houston, and hello Marie, and hello Steve. All right. This month our patrons voted for two plugins to be developed, or one major one and a small one. The main one is called the multi-variables node, and the smaller one is an elbow node. And we have prepared some code for you, so I'll run through both of those, and then I'll explain some of the more technical details on the actual implementation. All right. I'm just going to create a quick scene from scratch here. That's going to be a shape, just something that I can render. There we go. Go to the nodal editor for the surface. There it is. And I'm going to start with the multivariables node. That is going to be in the variables subsection. And you just add it. And what you will notice is that there's an empty interface here. Presets pop up. That allows you to load and save presets. And we have an empty node. Now, the point of this is basically to give you a central point to collect multiple variables, or as Lightwave likes to call them, constants, that control different parts of your nodal graph. So, for example, let me just render this. Let's assume that there's a certain color I want to reuse multiple times. So I right-click on the node, there's a node menu, and I can say, okay, add color. And that opens this window, and I can change the name. And I'm just going to call the output surface color. Now, as you notice, I just pressed return, nothing happened. That's because Lightwave didn't actually refresh the node editor yet. And to be fair, I can't really control that from our code side of things. So what you have to do is just click somewhere, and you will see that now we have an output called surface color. It's a color output. And if I click on the node again, you will also notice that there's a control here that gives you a normal color picker and even an envelope. And now I can use that elsewhere and maybe give it a color that's a bit nicer. Well, maybe not nicer, but that's our green. All right. So now you've added one control and one output, and you can use that in multiple locations within the current node graph. So I could, for example, just say, all right, I want my subsurface color, which in this case wouldn't do anything, to be the same, and you can hook it up to that. Or if you have some procedural textures like fractal noises or something, but you all want them to use the same color, you can also do it this way. Or I could, for example, say, all right, I want one control for the roughness, and you go to the node menu. In this case, you have to be careful because you can either click on the output itself. That gives you an option to edit or delete the current output. Or if you notice that I'm clicking further left on the node, if I right click here, this is where I get the general node menu. And let's just add a percentage, and I'm going to call this roughness. And if I click on node graph again, now I have a roughness output, and I have a roughness control here as well. And I can hook this up to the roughness, and that will modify the roughness of this surface. Now, the interesting thing is, let me just add another color. Let's call this secondary color. There we go. And I'll just set this to something like blue. Let me just quickly build something that's a bit of a sample scene. So we have one principal BSDF. I'm going to add another one. There we go. And I'll connect the secondary color to it and the roughness. And in this one, I'll connect the roughness as well. And I'm just going to add a material mixer and a simple fractal node. There we go. Move over here. And the whole idea is that I'm going to have two different materials. Come on. That I'm going to mix together using the fractal procedural. And that will in turn drive the surface. So if I look at this now, I get something like this. So I have a blue and a green principled material, and I'm mixing those together using this fractal noise thing. All right. Now, the interesting thing is that if you look at the way those two are hooked up, my two materials, the first one uses the surface color from the multivariables node. The second one uses the secondary color, but they both share the same roughness. So if I change the roughness here to, let's say, 50%, you don't really see much, but effectively both surfaces, both materials have their roughness property changed. And I can do the same with, let's add specular, for example. And that's also a percentage. Specular. There we go. There's the output. And I can add it to this. And I can add it to this. Let's see if changing that is going to make a difference. Yeah, there we go. So I've got specularity on both materials. That's a bit too much, maybe 30. Yeah, there we go. And this allows me to use one value to control two different materials in this case, so I could just control anything that you can hook up to. No, this is not NodeMeister. The difference between the multivariables and NodeMeister is that essentially multivariables is supposed to give you a single point with controls for the node graph that you're working on. So as opposed to jumping, through from one node to the other to set different values, if you have common values or values that you use often from different nodes, you just put them into this node, and that gives you one centralized location where you can edit all those values and assemble it any way you want to. NodeMeister allows you to do something similar, but the main use of NodeMeister is the fact that you can actually use one global node graph in multiple node editors. So I could have different surfaces that all use the same global node graph. This is something that the multivariables does not do. It's just a convenient way of basically merging different styles, different kinds of constant variables into one user interface. So essentially, if you look at vanilla Lightwave, you have these constant nodes here, where you have an angle, which does, yeah, there you go. You have an angle, you have a color, you have a direction, you have an integer, you have, okay, pi, you have a scalar, and you have a vector. And basically the multivariables node replaces all of these with a single user interface. And you can mix and match them as you want to. You can even do things like there's an integer and a Boolean. So an integer would just be something like this node, which gives you, any full number or negative number. And I've also added another option, which would be a Boolean. And let's just call this switcher. And you will notice that this just gives you a checkbox. And the output of that checkbox is 0 if it's not checked and 1 if it's checked. So one use case for the Boolean node, for example, and I just hope this works because I haven't tested this. I should be able to connect the switcher to the alpha channel of the material mixer. There we go. And the switcher is off, so it's showing me the green material. And now if I toggle it, that doesn't work. Okay. I suppose Lightwave doesn't really translate the value the way I'd like it to. I'll have to check that, but the idea would be that it would then toggle to the other input. At least, yeah, that's how it should work. It doesn't in this case. But yeah, that's what the multivariables node does. And yeah, the idea is just now to give you a nice user interface. And I suspect one of the questions is how can you edit this once you're done? What you can do at the moment, you can rename any of these values. So if I don't, like the label roughness, I right click on the roughness output, go to node menu, edit, and yeah, those don't work yet. I can only delete, but you will be able to rename those. One thing you won't be able to do, at least not for now, is change the order. Because that complicates things quite a lot when it comes to the order of the outputs in the nodes, especially if they're connected already. So yeah, that's something I'm kind of staying away from. Plus, it would need a different user interface as well. So yeah, you basically have to make sure that you create things in the right order. However, you do have the option of saving the whole thing as a preset, or even as a preset that you save to a file, and you can easily reorder it in there if you want to. I mean, it's a bit hacky and a workaround, but yeah, it works. All right, and since we already have a fairly convoluted node graph here, which does not need to render in the background, the other node that was added is the elbow. And the elbow is mainly just designed to declutter your node graphs in a way. So if you have many connections between nodes and maybe you're reusing the same output on different nodes, things can get messy quite quickly. And yes, I realize that this really isn't messy yet, but it could be. What the elbow node allows you to do, I'll just add that, is to basically reroute connections. So as you can see, if you add it, it doesn't have a user interface. There's nothing here, so I can actually close this down. And it just has a new input. Now the idea is that if you want to reroute, let's say that the surface color output here, because you've got that somewhere down here in your node graph, and there's something here that's in the way, and you want to reroute it in a nicer way, you can take the surface color, put it into the new input, and that creates a surface color output on the elbow as well. And now I can connect it to where the surface color output was connected to. And that basically allows you to route things in a different way. I can do the same with the roughness. Maybe connect the roughness to this, and let's use the specular as well. There we go. And as you can see, that allows you to basically control how the splines of your node graph are going to flow. And it doesn't process any of the nodes, any of the information that's being transported. It's an extension cable, exactly. Yeah, it's a universal extension cable with adapters for almost anything. It does also work with Octane. So any Octane specific connections, if you hook them up to the new input, will create a pass through as well. Um, the only kind of not really downside, but one of the things I'm not too happy about but can't change is that there's always a certain width that this node is going to be, and that's determined by the length of the names of the inputs and the outputs. Um, and since those have to be unique, and you actually want to know what you're connecting to, I decided to just keep those names here, not insert some really small ones. I mean, I could just call a color input C and a color output C as well, but then if you just look at the elbow node, you actually don't know what's being passed through unless you trace it back. So I decided to mirror the names of the outputs that are connected to it. And yeah, the elbow node was also going to be an example of how things are often not as simple as they seem to be when you're coding. And because you look at it and you say, okay, well, it's just passing through values. It's not really doing very much. Well, one thing it has to do, for example, is actually save the configuration for the node. It has to save which inputs there are and which outputs there are, because if you don't save those, then next time Lightwave loads this node graph, it won't find any inputs and outputs to hook up to. So this configuration is obviously saved with the file and load it back in. And if you look at it so far, it looks fairly simple. The problem is, what if you have multiple inputs that have the same name? And in this case, I'm just going to use the same specular input, but it will illustrate the idea. So if I hook up the specular again, you will notice, ooh, now it's called specular 2 in brackets. This is Lightwave doing that automatically. Internally, I'm just creating a new input and output, and I call them specular. But Lightwave sees that, oops, look, there is already a specular input, so I can't use that name, and it appends a number to it. And that's done behind the scenes by Lightwave. This is not my code. If I add another one, it's going to be, well, you can guess now, specular 3 exactly. And let me just add a few more. Okay, so if I save this, if Lightwave saves this, it will save the inputs and the outputs, and it will save them as being called surface color, roughness, specular, 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 specular. And when the settings are loaded in again into the node, let's say if you're reloading your scene or your surface, and then I tell Lightwave to create an input that's called surface color, roughness, specular, 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 and Lightwave will again append those numbers depending on the order of creation. And so far, that doesn't cause any trouble. However, in the elbow node, you're also supposed to be able to, maybe you don't actually use specular 3 anymore. You don't want that. You don't want to clutter the elbow node. So you actually want to be able to actually remove it. Now, if you do that, then without any more code magic, you would have an input called specular, specular 2, specular 4, because you just deleted the third one, and specular 5. The problem is that Lightwave actually uses the names of the inputs and the outputs to determine the connections in the node graph. So, we have something that's connected to the specular 4 input and the specular 5 input in this case. And if I just load the scene again like I would before, then Lightwave would create a specular, specular 2, specular 3, even though it was deleted, but it's the next one in the sequence, and a specular 4, it wouldn't create a specular 5 because I just removed one of those. And then the connections wouldn't work anymore. Because Lightwave thinks, okay, I've got something connected up to specular 5, but when loading, that's not going to work. Hello, Michael. So one thing I had to do is basically whenever you remove one of those inputs or input-output pairs, I'm actually renaming all the inputs and outputs again, just so that it's going to be consistent when it reloads the elbow node. So it doesn't do it right away because the node graph doesn't update. But if I click it now, you will notice that specular 2 and specular 3 and specular 4 are still there. Specular 5 is gone. But what effectively happened is that specular 4, the old one, was renamed to specular 3, and the old specular 5 was renamed to specular 4, and the connections actually still persist, which was the important thing. If you remove an input or an output, you don't want to lose the connections of the other ones. So let me just illustrate this again. If I take specular 2, for example, and remove it, what's going to happen is specular 3 is going to be renamed to 2, specular 4 is going to be renamed to 3, and the connections into them are still going to be there. So let's just remove this. I think that's this one. And it's still there. Clicking to update. And that's exactly what happens. So this way it can load and save. And when the elbow node is being loaded again, and it creates those nodes and inputs in the order that they were saved in, it will still get the correct names, and Lightwave will be able to use the right names to actually connect the elbow node to the other nodes. So yeah, that's just to give you an idea that, while something like this might look simple, there's always cases where you have to look out for and say, okay, well, that will need some more thinking just to make it work in a case like this. Obviously, if you never have inputs and outputs with the same name, it's not going to be a problem. But you're more likely than not going to have inputs and outputs with identical names. So it better be able to handle those. Yeah, what else can I say about the elbow? Not much, really. I mean, it works the way it's supposed to. Yeah, I would argue that's it for now. And also, yeah, these pop out. I will have to see what the output of the switcher is and why that doesn't actually work with the other switcher. Separate in and out node. Tricky. In a way, that might be what NodeMeister is for. But to be fair, I wouldn't know how to tell the node graph that it's basically one node that's split up into two different sections. I suspect that's almost impossible to do without actually changing the workings of the node graph itself, which is, Lightwave. And then it should be able to just break any kind of node into two different parts, I suppose. But yeah, yeah, tricky, and not easily done. You would probably need to have an elbow in, elbow out node, and then a pop-up on each to basically, or on one of them, to be able to select the sibling node. So if you're in the input node, you can, or the in elbow, you can select the out elbow so that they know that they're actually in connecting to each other, and then it should be possible. But yeah, it's not trivial. Absolutely not easy. So yeah, sorry, no split elbow. And it's certainly not going to be as easy as this. Also, when it comes to using it, because you would need to add two nodes, and then at least in one of them, tell it what the other one is, and then they can start communicating with each other. But yeah, that's all there is for this month. Of course, the question is, do you have any questions, any suggestions, anything that isn't clear, anything that you would like to see? Um, Reading the chat. Now I'm gonna take a sip of coffee and maybe hear some questions and go some comments. Oh, a NodeMeister, super awesome. But yeah, I mean, it's essentially the multivariables is kind of a NodeMeister spin-off in a way that in the NodeMeister node, it can also display controls, and you can add inputs or well outputs to the NodeMeister graph itself, and have that being driven by the user interface of the NodeMeister node. Yeah, sorry, Steph, no live cooking this month. Oh, yeah, I can already see us doing a live lasagna cooking stream. But it will probably have to be a vegan lasagna. I could show some NodeMeister, but yeah, that's not really the development stream. But sure. If I find well, if I find some demo scenes, it's going to be tricky. Just a second. Yeah, the problem is she always comes up with ideas I'm not prepared for. Let's see. Which one should I take? Well, yeah, I've got something called a simple demo. That should do it. Yeah, okay. So, I mean, basically what we have here is we have a couple of primitives and they all have their own surface. There we go. And they all have their own node graph. And the idea is that, you know, in this case, I've got these different surfaces and I actually want them to, let's say, be textured using the same procedural. So, do I actually have NodeMeister installed here? Yes, I do. Wrong one. There we go. And do I have an... Yeah, I've got a global graph. All right. And basically, this is already using a global node graph. Now, if I switch to that, then you will say, oh, okay, this one contains a simple color corrector. It's not the one I want. Let me just go back here. All right. So I'm going to create a new graph, and I'm going to call this procedural. And it switches to that already. And I'm going to add some multifractal. This is going to have a color output. There we go. And here I'm going to add a new output that is BE color, and I'm going to add another one called FG color, and I'm going to hook these up to the procedural. So basically what I'm doing, I've got this multifractal here. I'm driving the colors from the input of the node graph, and the color goes to the output. And this is a NodeMeister-centric node graph. And if I go to the NodeMeister into the input or the output, I can open the previous node graph, which is my surface. And you will see that the NodeMeister node itself now has a BG color and a background foreground color input and a color output. And if I hook this up, then it should, they're both white. I just use two really nice colors. And obviously the other one has to be green. There we go. And you will see that I have a procedural now that's on this torus. Well, I could show them your crazy rig if I had it, but I don't, so I can't. All right. So on one of my surfaces, the toroid, I now have this procedural attached to it. And it's driven by the settings in here by these two colors. Now let's say I go to my sphere, open a node graph here, and I want to actually apply the same procedural. So I'm going to add a NodeMeister node here as well. And you see that the NodeMeister graph it uses is the procedural. That's the one that I've just created. And I'm hooking this up to the sphere. Nothing happens because the input colors are white. But in this case, I'm going to use, let's make it blue and purple as input colors. Yeah, maybe not purple. Maybe something that's a bit of more contrasty, like the yellow. And you will see that the sphere is now being shaded using the same procedural, but with two different colors because those are the inputs into NodeMeister. And I could do the same with the cube. Let's just quickly do that. Use two different terrible colors, cyan, and what's, yes, use red. All right, so these are all shaded using the same procedurals. Now what's interesting about this is I can go to the global NodeMeister graph. That's the one that's being used by all three nodes that take part in shading. And let's just replace the multifractal with the multifractal procedural with, what shall we call it? Which one? Marble is too similar. Crackle, I think, is, yeah, Crackle is okay. No, Crackle is too similar as well. Dots might work. All right. So basically what I'm doing now is replacing this multifractal with the dots. Background color, foreground color. And yeah, it doesn't show much. But essentially what happens now is that all three surfaces now use the dots procedural as opposed to the multifractal that they used before. Or again, using two different color inputs for every surface. And that's the general idea of NodeMeister, that it gives you a node graph that's being shared by multiple other node graphs using the NodeMeister node. So essentially everywhere this, let's go back to the cube, everywhere this node is being used, which in this case references the procedural NodeMeister graph, this whole thing is going to be evaluated. And you can change this centrally, and it's going to update in all the cases where it's being used. And that can be a surface, but it can also be a motion or any other place where a node graph can be used, lights, displacements, etc. And that's generally the idea of NodeMeister. And if you look at the similarities between NodeMeister and multivariable, then it's essentially the fact that I did create, if I go to the graph, I created two outputs here, the BG color, background and foreground color. And if you go to the NodeMeister node itself, then it also has these two controls as inputs. And that's essentially the part that was more or less ripped out from the from NodeMeister and put into the multivariables node. That's the only similarity, I suppose. So yeah, that's NodeMeister in a nutshell. And let's see if you have any more questions. then give us a shout. Otherwise, we'll let Marie get back to her family. Yes, I couldn't resist. Sorry, Mike. We'll let Marie get back to her family and, yeah, leave you off to the night on your own, hopefully. Hashtag no corona. I mean, the least good thing here is that we don't have the problem of having to shake hands or anything. So yeah, that's essentially all there is. I mean, yeah, that's all I prepared to talk for. anything, anything beyond this would just be waffling, unless you have questions, which you don't. But if you um, do get in touch with us on Discord. And yeah, since except for one or two things, this is working as it should. I will be sending out a first build tomorrow by the looks of it for everybody. And then you can have a play, and we should have the Q&A not next week, but the week after, because I won't be here for the weekend. And that should give you, 2 weeks to look at it and maybe come up with things that you think are missing or that you would like to see changed. And we'll try to get those fixed either before or after the Q&A. All right, that's fair enough. So Mike's gonna rewatch the stream. Great, thanks. And yeah, I'll see you guys around. See you in the Discord. Again, thanks to all our patrons for supporting us. And yeah, spread the word. And as other streamers say, click the subscribe button. And we'll see you around. All right, thank you. Good night. Bye bye.